Okay, yesterday we discussed a part, well, actually the last few days, we discussed the part of the flux capacitor here, and it was dealing with this part right here, moles and representative particles, and going up and down in this direction. Now, today, our objective is to be able to do this top part. The moles right here, okay, right here, converting those to mass. So we're going to go moles to mass, mass to moles, and what you're eventually going to see is that we can use the moles as a middleman. So if I give you the mass, you can convert it to a mole, then you can convert it to a representative particle. Let's say that representative particle would be a formula unit. Could you then do another step and convert it to an atom? Okay, hopefully that's the goal, because that's going to be as big as we get with this stuff, folks. That's going to be as tough as it comes. Taking it from a mass to a mole to a formula unit, then to an atom. So that would be what, 1, 2, 3 steps? That's going to be as good as it comes with these molar conversions. Now, when we're dealing with the molar conversion, we don't have any new material because you've already done the molar mass, haven't you? I graded a WebAssign the WebAssign was due on Monday. I put that in the computer yesterday, but we've already done the molar mass. All it was the calculation from the periodic table. So, if I am starting off with a mole, if I am given a mole and want to convert into a mass, my conversion box that I'm going to use is, on the bottom is going to be 1 mole of whatever the substance is, and on the top is the molar mass. Now, unlike Avogadro's number, the molar mass changes. For instance, if I'm looking at Avogadro's number of 1 mole of carbon, it's 6.022 times 10 to the 23rd. If I'm looking at 1 mole of oxygen, how many atoms? It's 6.022 times 10 to the 23rd. Avogadro's number does not change, but the mass of 1 mole of carbon, look at your periodic table, 12.011 grams. The mass of 1 mole of oxygen, 15.9994 grams. 12, 15, they're not the same, are they? So these masses will change. Okay, these masses will change. If I'm doing the flip side, folks, on the other side, if I'm going to mass and I'm going down on the red arrow there, I'm going to have on the top 1 mole and on the bottom the molar mass. So that is this part of the flux capacitor that you should have got from the video, and hopefully you have already had that copied down, that is just a review for you. Now, however, let's work some problems. Go ahead and copy that down. How many moles are in 5.42 grams of chromium-3 sulfate? Now, the very first part that I want you to do And it's a good review for us, folks. It's a good review for us. I want you to write the formula for chromium 3 sulfate and then find the molar mass. Okay, now when I have done this, ladies and gentlemen, chromium sulfate. Sulfate is a 2-, chromium is a 3+. So that is my formula for chromium 3 sulfate. Now some people, and like I said, I've been preaching and preaching, some people I'm already predicting are going to fail the rest of this stuff because they're not taking it serious how important naming formulas are. Now, if I look at chromium 3 sulfate, I came up with a molar mass of 392.18 grams. Now, all I'm doing with the rest of this stuff is just the flux capacitor. I take what I'm given, 5.42 grams of chromium 3 sulfate, and I put my conversion box. Even though it's not up here on the board, I can see that I'm given a mass, so I'm starting at the top. I'm going to moles, which is the middle. That tells me that I need to have 1 mole of, I don't know what happened there, 1 mole of chromium 3 sulfate on the top. On the bottom is going to be my molar mass, which I just calculated, 392.18 grams of chromium 2 sulfate. When I do my math, I'm going to bring my answer down here. So I am going to take the 5.42 grams, multiply that by 1, then divide by 392.18, and I'm going to get a value that tells me that it is 0.0138201. I'm going to cut it off there because I've got plenty of numbers. I come back to my original number given, and I have 3 significant digits. So I'm going to round this to 3 significant figures, which is going to be that value right there. I look back up here. I've got grams here to cancel. What is my final label going to be? Moles of chromium 3 sulfate. Moles of chromium 3 sulfate. Questions? Well, let's move on to another one then. Go ahead and get this copied down, and then we will work. Actually, folks, once you get this copied down, let's just do all those first steps. Get it copied down and find the molar mass, and then we'll work it. So get this copied down, find the molar mass, and we'll work it up on the board. All right, ladies and gentlemen, once again, we're going to start off here writing the formula for sulfur 4 oxide. This is the stock system. This is the stock system. I'm naming 2 nonmetals, so it's molecular stock system. So it says sulfur has a 4 charge. Okay, I know based on my oxidation numbers that oxygen is either 2 minus or 1 minus if it's a peroxide. Is this a peroxide? Does it say peroxide? No, it does not. So oxygen has a 2 minus charge. Sulfur's 4 plus, oxygen's 2 minus. So my formula is simply SO2. When I calculated my molar mass for SO2, I got 64.0638 grams. Would we agree on that? I'm not going to round anything yet, okay? Like I said yesterday, I'm not going to worry about any sig figs until the very end. Because once I start rounding, and then I round my next number, and then I round my next number, if I've got a 4-step problem, I've rounded a lot. Okay, I've rounded, 4 different times. Okay, so I just leave my rounding go until the end. Now, I look at what is given to me in the problem. 3.48 moles of sulfur dioxide. So if I look at my flux capacitor, I'm starting in the middle, aren't I? And I'm working up to moles. So that tells me that my conversion box needs to have 1 mole of sulfur dioxide on the bottom, and I'm going to have the molar mass 64.0638 grams sulfur dioxide on the top. I do my math, draw my arrow to where I'm bringing my answer down to. So I'm taking the 3.48 and I'm multiplying it by the 64.0638, and I'm coming up with an answer that has 3 significant figures. So my answer is going to be 223 grams of SO2. 223 grams of SO2. Any questions on this problem? Once again, I don't think the hard part is the flux capacitor stuff. I think the hard part is the stuff we've done previously, the naming. Now we're getting a little bit more challenging here, folks. We're getting a little bit more challenging because I don't have mass or I don't have moles. Okay? Go ahead and write down this problem. What is the mass of 9.4 times 10 to the 24 molecules of diphosphorus pentabromide? What I would want you to do then, after you get that, we're going to need the molar mass eventually. So go ahead and calculate the molar mass of diphosphorus pentabromide, and then we'll work the problem. Now for this particular problem, I'm going to pull back up my flux capacitor. Okay? I'm going to pull back up my flux capacitor. Doesn't erase very good, but hey, nonetheless. Now, we were given a value And that value was labeled what? That value was labeled molecules, correct? So where am I starting at? I'm down here at representative particles. Is there a line that takes me representative particles straight to the mass? No. So this is a two-part problem. I've got to use a middleman. So I've got to first go to moles, then I'm going to go to mass. So we're going to put together what you did a couple of days ago and what we're doing today. So once again, I start off with writing the formula, which is diphosphorus. It looks like I have prefix method this time. Diphosphorus pentabromide. What's penta? 5. So there is my formula. When I do my molar mass for that, I have 461.4676 grams. So that is the amount of grams per 1 mole. Now, as I work my problem, I come back to my original value. 9.4 times 10 to the 24th molecules of diphosphorus pentabromide. And on my flux capacitor, I'm starting at representative particles and I'm going to moles. So I know that on top is 1 mole phosphorus pentabromide. On bottom is 6.022 times 10 to the 23rd molecules of diphosphorus pentabromide. That's a step similar to what we did a couple of days ago using Avogadro's number. Now, when I look, my molecules cancel. I've converted this to moles. So I'm going to bring this down all the way over here. Here comes my answer all the way over there. And it is going to be 9.4 times 10 to the 24th. And I'm going to divide that by Avogadro's number. And that's going to give me a value. That's going to give me a value of 15.609432. And I'm going to leave that whole number. There's a couple more digits, but I think I have enough to round this later on. I'm going to leave that whole number there because I don't want to round yet. And my label is moles of P2Br5. Now, I'm not done yet, am I? I'm not done yet because I wanted a mass. Now I'm at moles, and I have to convert this to a mass. Well, when I have moles, I'm in the middle. When I'm going up to the mass, I know that I want 1 mole on the bottom to cancel. My molar mass was 461.4676 grams. So when I do so, I'm going to extend my page down slightly, maybe not that much. When I do so, I'm going to bring my answer down here with my little arrow. So I take that value, that 15.60943, 0.208, and I'm going to multiply that by my molar mass, which was 461.4676, and I'm going to come up with a value of, and I need 2 sig figs, right? If I remember right, it was 9.4, correct? I need 2 sig figs, so my value is 7,200 grams of P2Br5. My moles cancel here, meaning my label left is P grams of P2Br5. I only have 2 significant figures. If I would put that, that would make it 4. Okay? So I 2 sig figged it. 7,200. Those last 2 zeros are placeholders for my 2 significant figures. Yeah. If you put it into scientific notation, 7.2 times 10 to the third, that is the exact same number as what I have written there. So that is perfectly fine. Okay? Sometimes it's easier to put it in scientific notation with sig figs than it is to sig fig it like this. Okay? Do I have questions here? Okay, now what I would like you to do, I have one more example. I am going to pull that example up, and I want you to work it. Okay? You work this example. If you have questions, we're going to work this probably at the start of the next period. If you have questions, raise your hand and ask them. I will help you through it. Once again, folks, checking this out, I'm going to go ahead and work through it. The beauty of everything with chemistry is it is building. Okay? It is building, building, building. And how good is your foundation? If your foundation's not very good, then you're not going to build a very good house. I could go back and show you right now that our greenhouse back there is actually settling because it's probably got bad footers. And eventually, if nothing happens, it could possibly fall off. We're starting to call it California because it's on that fault line and might fall into the ocean. Okay? But nonetheless, the foundation, can we name? Okay? And you're going to see, I threw all different types of stuff at you today. I threw an ionic one. I threw a molecular one with the stock system. I threw the prefixes at you. Now the last one, I'm going to throw an acid at you. Now, the big thing, do I have bromate memorized? No, I do not. I needed to look off an ion sheet just like you did, okay? Because I don't, or excuse me, bromate, benzoate, okay? Because I don't have benzoate memorized. But benzoate is C7H5O2, and it's a -1 charge. Now, let me ask you this, first of all. What acid rule are we using right here? 1, 2, or 3? This is rule number 3. Okay? Rule number 3. Your question? Yes, I'm not finished with it. Yeah, you're correct. And she said, wouldn't you have to put a hydrogen out front with it? Yeah, I have to get rid of that charge. So my formula for benzoic acid is HC7H5O2. When I came up with my mass, my molar mass was 122.1232 grams. Now, I look at this and I see what I have. I have been given grams. and they ask me how many hydrogen atoms. Now this is one that I told you is going to be as good as it gets, because open up to your flux capacitor, and follow with me. Put your finger on where we are starting, which is the mass. Okay? We are starting at the mass. So I have to go from mass to moles, correct? That is my first step. Then I have to go from moles to representative particles, which is my second step. And then I have to go from representative particles to hydrogen atoms, which is my third step. This is a three-step problem. If you haven't done a three-step problem to do this, you're not right. Okay? You're not right. So, what I'm going to do is I'm going to start with my very first step, converting my mass converting my mass of benzoic acid into a mole. Okay, so my moles of benzoic acid I complete my box, and I always go back and look. I have grams here, I have grams here, my grams cancel. So my new label that I'm going to bring all the way over here is going to be a mole of something. So I take the 5.49 and I divide it by 122.1232, and I get a value of 0.0449546, and I'm going to leave that number pretty big, like I said, moles of HC7H5O2. So I have now converted that into moles. Okay, I've now converted that into moles. Now, I need to go to representative particles. Now, I'm going to say this because I think I might have done it wrong yesterday with my labels. I'm going to label acids as molecules. Okay, I'm going to label an acid as a molecule, so make a note of that if we did it, because I think we did it wrong yesterday. I think we called it a formula unit, but let's call it a molecule. So I'm going to go from moles to molecules using Avogadro's number. So I know that 1 mole of benzoic acid has Avogadro's number, molecules of benzoic acid I'm going to bring down my page a bit. Okay? So now my moles cancel, I'm going to convert this into molecules. So I take that number, that 0.04459, and I multiply that by Avogadro's number. And I come up with a value of 2.70766 molecules of benzoic acid. I I hear some rumbling. We got a question over that step? No? Okay.
Teachers, sorry to interruption, but I need the following students for the attendance check. Alyssa Long, Desmond Kittle, Bailey Louch, Angelica Romana, and Zach Shin. Thanks.
Now my final step is I need to go to hydrogen atoms, right? That's what I was asked for, right? I can't see the problem. Hydrogen atoms. So I do my conversion box here and I say, okay, I know that one molecule of benzoic acid has how many hydrogen atoms? 6. So as I extend my page down even more, I'm going to bring this down here. So I'm going to get my answer now. My molecules cancel. My label is going to be atoms of hydrogen. Atoms of hydrogen. So I'm going to take the number I've got, that 2.70. You know what? I did it myself. I told you guys not to do it. I missed that 10 to the 22nd on the back of that. Good thing I showed my work, huh? Okay, but it was still in my calculator. It was still in my calculator, but I missed that. So I got that up there now, thank goodness. Okay, so I multiply that number by 6, and I get a value. And how many sig figs do I need? 3 sig figs. So I get a value of 1.62 times 10 to the 23rd. Atoms of hydrogen. And like I said, of this stuff that we are doing right now, folks, this is as good as it gets. Okay? Of this stuff right now. Okay? Right now. Not in chemistry, right now. That guy that's called stoichiometry, he's a lot tougher than this. Okay? But this, as far as molar conversions, this problem right here is as tough as you will see, because it went from mass to moles, moles to particles, particles to atoms. Okay? It was a 3-stepper. Now, that is all that I have for you. If